Picture this: Earth, our home, being jostled by a cosmic event billions of light years away. Sounds incredible, right? Well, it happened. Our planet experienced a slight tremor, a ripple in the very fabric of space-time itself, like a gentle shiver running through the cosmos. The culprit, a star, or rather its spectacular and cataclysmic demise. You see, stars aren't immortal. They have lifespans, just like us, and when some stars reach the end of their lives, they don't go quietly into the night. They explode with the energy of a billion suns, releasing a burst of the most energetic radiation known to exist. Gamma rays, which can travel across the universe. This isn't science fiction, folks. This is the universe we live in. A universe teeming with wonder, beauty, and yes, even a little bit of danger. But it's also a universe that holds clues to our very existence, whispering secrets through the cosmic winds. Imagine a star much more massive than our own sun reaching the end of its life. Its core collapses in on itself, creating a black hole or a superdense neutron star, a fate sealed by the relentless pull of gravity. This collapse is nothing short of catastrophic. It unleashes shockwaves that tear through the star's outer layers with unimaginable force. The result? A supernova explosion of staggering power, a cosmic event that reshapes the very fabric of space. But the drama doesn't end there. Along the star's axis of rotation, focused jets of energy erupt at nearly the speed of light, piercing the cosmos. These jets are like cosmic blowtorches, spewing out gamma rays with a ferocity that defies comprehension. This, my friends, is a gamma ray burst, or GRB for short, a beacon of destruction and creation. They are the most powerful explosions in the universe, outshining entire galaxies for a brief but unforgettable moment, a testament to the star's dramatic end and its lasting legacy. GRBs are not all created equal. Some, the long-duration bursts, last for several seconds or even minutes. These are the death cries of massive stars, the kind we've been discussing. Others, the short-duration bursts, last for mere milliseconds. These are thought to be caused by the collision of two neutron stars, those bizarre remnants of stellar explosions. The GRB we're discussing today was a long-duration burst, a cosmic blast that traveled for billions of years before reaching our little corner of the universe. But even from that incredible distance, its effects were felt. Gamma rays are invisible to our eyes, thankfully. But their energy can ionize atoms, stripping them of their electrons. And that's precisely what happened when the wave of gamma rays from that distant star washed over Earth. Scientists believe that the mechanics behind these bursts involve the core collapse of massive stars, leading to the formation of jets that shoot out at nearly the speed of light. Detecting these bursts requires sophisticated instruments, as they are often fleeting and incredibly distant. After the initial burst, an afterglow can sometimes be observed, providing further clues about the burst's origin and the environment around it. Researchers continue to analyze data from these events to unravel the mysteries of the universe, from the life cycles of stars to the nature of space-time itself. Our planet's atmosphere, usually our protective shield, was briefly altered. This alteration was not something we could see with the naked eye, but it was significant enough to be detected by our instruments. The gamma rays ionized the upper layers of our atmosphere, creating a surge of charged particles. These particles, usually kept in check by our magnetic field, suddenly found themselves in a state of chaos. This ionization, in turn, disturbed the ionosphere, the region responsible for reflecting radio waves. The ionosphere, a crucial layer for communication, became a turbulent sea of charged particles. The result? A slight but detectable disruption to radio communications. This disruption, though minor, was a clear indication of the power of cosmic events. It was like a whisper, a fleeting echo of a cataclysmic event from a distant realm. This whisper traveled across the vastness of space, reaching our planet and leaving its mark. But it was enough to remind us that we are not alone, that we are part of a vast and interconnected cosmos. Every event, no matter how distant, has the potential to affect us. This wasn't a direct hit, mind you. The gamma ray burst, or GRB, originated from a star many light years away. If the GRB had originated from a star much closer, say within a few thousand light years, the consequences would have been far more severe. The energy released would have been exponentially greater. We're talking potential ozone layer depletion, increased radiation exposure on the surface, and possibly even mass extinctions. The delicate balance of life on Earth could have been thrown into chaos, reminding us of the fragility of our existence in the universe. The tremor felt on Earth was not just a metaphorical one. Sensitive instruments like seismographs and global sensor networks picked up the subtle vibrations caused by the gamma-ray burst. Scientists around the world analyzed this data, piecing together the story of this distant explosion. This event highlighted the importance of global collaboration in science. Data sharing among scientists allowed for a comprehensive understanding of the impact, showcasing the interconnectedness of our world in the face of cosmic phenomena. Ultimately, the tremor served as a reminder of our planet's vulnerability and the protective role of our atmosphere and magnetic field. It underscored the need to continue studying and understanding these cosmic events to better prepare for any future occurrences. So, how do we even know about this distant explosion? Enter our cosmic detectives scientists and their incredible instruments. Orbiting Earth are satellites designed to detect these high-energy bursts from space. They act like cosmic burglar alarms, alerting us to these incredible events. When the gamma-ray burst occurred, these satellites lit up like Christmas trees. They meticulously recorded the intensity, duration, and even the direction of the gamma rays. Back on Earth, other instruments detected the subtle changes in our ionosphere, confirming the impact of this distant event. It was a team effort, showcasing the dedication and expertise of our cosmic detectives. Their findings highlighted the importance of continued observation and study of these powerful events, driving our quest to understand the universe. Now, you might be thinking, Neil, why should I care about an explosion billions of light years away? And it's a fair question. After all, it's easy to feel detached from something so far removed from our daily lives. This gamma-ray burst posed no real threat to us, and it's true that such events are incredibly rare, but it serves as a stark reminder of the awesome power of the universe and our place within it. The universe is vast and full of wonders, but also dangers. Gamma-ray bursts are rare, yes, but they do happen. These bursts are the most energetic events since the Big Bang, and while the odds of a nearby gamma-ray burst directly impacting Earth are extremely low, they are not zero. The potential consequences, though unlikely, could be catastrophic. Understanding these events, their causes and their potential effects is crucial to our long-term survival as a species. It's about being prepared for the unexpected. Think of it as cosmic insurance. Just as we prepare for natural disasters on Earth, we must also consider cosmic events. The more we know about the universe, the better equipped we are to face any challenges it may throw our way. Knowledge is our best defense against the unknown. By studying these phenomena, we not only protect our planet, but also expand our understanding of the cosmos, enriching our place in the universe. This distant threat is a stark reminder that we are part of a much larger cosmic tapestry, one that demands our respect and vigilance. But this isn't just about mitigating risks. Studying gamma-ray bursts provides us with a unique opportunity to peer into the most extreme environments in the universe. They offer clues about the life cycle of stars, the nature of gravity, and the very fabric of space-time. By analyzing the light from these bursts, scientists can decipher the chemical composition of distant galaxies and learn about the conditions present during the early universe. The light spectra from these bursts reveal the presence of elements, allowing us to map the chemical evolution of the cosmos. It's like cosmic archaeology, using the light from these explosions to piece together the history of the cosmos. Each gamma-ray burst is a data point, a piece of the puzzle that helps us to better understand our place in the grand scheme of things. Through advanced simulations and complex algorithms, we decode the cosmic messages embedded in these bursts, unlocking secrets of the universe. The story of this gamma-ray burst is a profound reminder that humanity and the cosmos are deeply intertwined. These bursts, among the most energetic events in the universe, release more energy in a few seconds than our sun will in its entire lifetime. They serve as cosmic beacons, illuminating the intricate dance of celestial bodies and the forces that bind them, reflecting our own journey through existence. Events happening billions of light years away can and do affect us here on Earth. The light from these distant explosions travels across the universe, carrying with it stories of creation, destruction, and rebirth. These cosmic waves, though invisible to the naked eye, ripple through the fabric of space-time, influencing the very nature of our existence and our shared destiny. We are not isolated islands in the vastness of space, but rather integral parts of a grand, interconnected web. This cosmic web, a vast network of galaxies and dark matter, binds the universe together, creating a tapestry of interstellar connections. Each galaxy, each star, each planet is a thread in this magnificent fabric, contributing to the overall structure and beauty of the cosmos, and to our collective fate. The universe is full of wonders, but it also holds dangers. Nebulae, the birthplaces of stars, are also sites of violent supernova explosions. These cataclysmic events, while destructive, are essential for the creation of new stars and planets. They scatter elements across the cosmos, seeding the universe with the building blocks of life and shaping the destiny of future worlds. By studying these events, by unraveling the mysteries of the cosmos, we gain a deeper appreciation for the fragility of our own existence and the importance of safeguarding our planet. Astronomers and scientists dedicate their lives to observing the skies, using advanced telescopes and research facilities to decode the messages written in the stars. Their work not only expands our knowledge, but also reminds us of our place in the universe and our role in its ongoing story. So the next time you look up at the night sky, remember this: those twinkling points of light are not just stars, they're cosmic storytellers, each with a tale to tell about the universe we call home. They are the narrators of our intertwined destiny, connecting us to the vast expanse of space and time, and reminding us of the infinite possibilities that lie beyond our world and our shared journey through the cosmos.